In this video we will be solving exponential equations. Let's start here. If an exponential equation reduces to the form b raised to the p power is equal to b raised to the q power, where the base is between 0 and 1, or the base is greater than 1, then that implies that p, this exponent, has to be equal to q, this exponent. So since exponential functions are one-to-one, that has to be true. So what that means is we're going to be working through these problems. We're going to try to reduce it down, simplify it down to this form right here, and then drop the bases and set the exponents equal to one another and solve for our variable. That will be the basic process. So that's a little wordy. So let's just take a look at some examples here. So example 1, 3 squared times 3 to the x power is equal to 9 to the negative x power. So we can rewrite this. 3 squared times 3 to the x equals 9 is the same thing as 3 squared, and then raise that to the negative x power. So we can do some simplifying here. We have like bases being multiplied here, so we're applying our exponent rules. So that means we add the exponents. So we'll add that 2 plus x. So we get 3 raised to the 2 plus x power, and that's equal to, then this side we have outside to inside. So our rules told us in the previous lessons that we multiply those exponents. So we'll have 3 raised to the negative 2x power. So now we have it in this form right here, so we can just drop these bases, because the bases are the same, set the exponents equal to one another, and solve. So that's what we're going to do. Off to the side here. So we have 2 plus x, that's this exponent. We're going to set that equal to this exponent, negative 2x, and then just solve. So we'll subtract this x here. We get 2 equals negative 3x, divide by negative 3, and finally we have x equals negative 2/3, and that will be our answer. So we solved example 1 there, x equals negative 2/3. Alright, here we are with example 2. So we have 4 raised to the x plus 1 power equals the square root of 8. So we'll start breaking this down a little bit. We'll rewrite square root of 8 as 8 to the 1/2 power. Remember, taking the square root, same thing as raising to the 1/2 power. Now we have them both set up with exponents. No, we got rid of this root right here. Now we need to establish like bases. Remember, in our rules, we want one base matching the other base on the other side, set the exponents equal to one another, and solve. That's our process. So we have a base of 4 here, a base of 8 here. We can rewrite those with a base of 2, because 4 is 2 squared. Raise that to the x plus 1 power. So this 4 is this 2 squared, same thing, still raised to the x plus 1 power. Equals 8 is the same thing as 2 cubed. That's raised to the 1/2 power still. So this 8 is that 2 cubed, still raised to this 1/2 power there. So now we have outside to inside, so we're multiplying. So 2 times the quantity x plus 1. Remember, we have to multiply the 2 times the x and the 2 times the 1. So we get 2 raised to the power of 2x plus 2. Okay, 2 times x, 2x, 2 times 1, 2. So that's where this comes from. Equals 3 times 1/2, because it's outside to inside again, so we multiply. 3 times 1/2 is 3/2. So 2 to the 3/2 power. So now we have like bases, 2 and 2. So we drop those bases, set the exponents equal to one another, and solve. So 2x plus 2 is equal to 3/2. We just took the exponents, set them equal, and now we'll solve. So we'll subtract 2 here, subtract 2 here. So 2x equals, 2 is the same thing as 4/2, so I'll mark that out, make it 4/2. So 3/2 minus 4/2 is minus 1/2, and then divide that by 2. Dividing by 2 is the same thing as multiplying by 1/2, right? So negative 1/2 times 1/2 is negative 1/4, so x equals negative 1/4. So we're done with example 2. Let's move to example 3. Alright, here we are with example 3. So we want to get it in the form b raised to the p power is equal to the same base raised to the q power, right? That's the way we want it. So we need to work with this to start making it look like this. So let's do that. Let's take this negative 2 to the x plus 5 over here so that it looks closer to what we need. So 8 to the x power equals 2 to the x plus 5. All I did is add this term to both sides, brought it over here. This side was 0, so now it's just this part right here. So now looking at it, it's starting to look correct, but the bases don't match. I have a base of 2 here, a base of 8 here. So I know that I can rewrite 8 as 2 cubed. 2 cubed is the same thing as 8, still raised to this x power here, equals 2 to the x plus 5. Now outside to inside right here, multiply those, so finally 2 to the 3x equals 2 to the x plus 5 power. So now I have like bases set equal to one another, so now I take their exponents and set those equal and solve. That's our process, same as the other problem. So 3x equals x plus 5. Subtract x, we get 2x equals 5. Divide 5, divide 2, and we get x equals 5 halves. So that solves example 3, x equals 5 halves. Let's go on to example 4 next. Alright, example 4, a little more complicated this time. Often when we're solving, we need to look to see if we can factor along the way, especially when we see it set equal to 0. And that's what we're going to need to do here. If you notice, we can factor out an x out of those two terms. So that's what we're going to do. So factor out the x, and you're left with this becomes e to the x power. We took out this x right here, and then minus e to the 2x plus 1 power equals 0. So we factored out that x. If you distribute the x back in, you'll end right back here where you started, so you know it's right. So that means these two things, x and this quantity right here, multiplied together have to equal 0. So that means either x has to be 0, so this one has to be 0, or this one has to be 0. So we actually have a solution right here. This x is 0. We still need to work with this one though. So we take that one, e to the x minus e to the 2x plus 1, set it equal to 0 and solve. Just like when you factor quadratics, it's not any different. You set each factor equal to 0 and solve. So this one is similar to the previous problem. We're going to take this term over to the other side and it will become positive. It's a subtract over here, so it'll be a positive over here on the right side. So we'll do that first. So we get e to the x, that's this original e to the x, is equal to e to the 2x plus 1. So that's this term moved over here to this side. Now we have like bases. We have base e, and we just set the exponents equal to one another and solve. So we get, let's do that in this pink color like we've been doing. So x equals 2x plus 1. We have like bases again, so we drop those bases, set the exponents equal to one another and solve. That's what we're doing, same as always. So we will subtract 2x here. So we get negative x equals 1. So we'll divide by negative 1. And we get x equals negative 1. So we have two solutions in this case. We have x equals negative 1 and we have x equals 0. So both of those are our solutions to example 4. So just to recap quickly, we want to get these in the form of a base raised to a power is equal to the same base raised to another power. And then we can say that p equals q and we solve from there. So we set the exponents equal to one another and solve. So that's our basic process for each one of these. Alright, that is it for lesson 5.